The next step is to add our active grid component. We'll do that by creating another empty game object, choosing active grid for our name, go into component menu, dynamic loading kit, main components, and choose active grid. First thing you'll notice is the grid ID. Like the world ID, the grid ID only needs to be changed if you have multiple active grids in the same scene. So for now, since this is our first active grid and we don't have any other active grids, we can just leave it at its default value of 0. These default values here, everything underneath this label that says defaults, all of these values will only be used when no persistent data exists for the active grid. So as soon as you save some persistent data, these values are no longer used. Now, if you want to go back to using these default values, you can go to your persistent data controller and choose clear, let's see, clear inspector created active grid data, and then enter the ID of the active grid that you want to clear and hit clear. Obviously that wouldn't do anything now though because we have no persistent data. So the first thing you'll see under this default section is the world. This is the default world that your active grid will sync to. We'll drag our world game object here, which will link our world component to this field, and you'll see it has a little indication of what the world ID that active grid is synced to. The next part is the grid dimensions. These define the dimensions of the active grid. They define the both the dimensions of the inner area and the outer ring width. Hopefully you watched the last video in which I described what the inner area and outer area were. If not, I'll provide a brief overview. The inner area is an area of the active grid that the player can run around without activating a dynamic shift. So as long as the player remains in this green area, the active grid does not shift. As soon as he crosses one of these boundaries, the active grid shifts in the direction of the boundary crossed. So we define the dimensions of this inner area by defining the number of inner area rows, inner area columns, and you also see inner area layers, but that's only used when this active grid is synced to a 3-dimensional world. For now, our world is 2-dimensional, so we don't need to worry about it. So if we specify an inner rows to 1 and inner columns to 1, then we will simply have a single cell for our inner area. That's no fun though, so we can increase that. And the outer ring width defines the area of this outer ring. And these are simply additional terrains that are loaded around the inner area. This ensures that as the player crosses one of these boundaries, he actually has an object to walk onto. The next thing you'll see here is the index of the first cell in the grid. This is used only when a player is not present. If a player is present, then the active grid is actually constructed around the player. So more than likely you will not need to set these values. You can also see here a value or an option called Cell Users Enabled. This defines whether the user requests are actually sent to the world that the active grid is synced to for the activated cells in the active grid. So if this option is disabled, then the active grid exists, but the user requests for that active grid, for the cells in that active grid, are not sent to the world, and therefore, in all likelihood, the objects associated with those cells will not be loaded into the scene. Now you may have another active grid that's synced to the same world that does have its cell users enabled, and if there's some crossover between those two active grids, then the objects may be loaded. Most likely you'll want to leave this option enabled. The next option is the player. This is the transform of the player that you want to be associated with this active grid. It's the transform that will be tracked to determine whether the grid needs to be dynamically shifted. As I said in the previous video, you do not need to provide a player. You can shift the active grid manually via method calls. In all likelihood, though, you will want to use dynamic loading. I mean, that is why you're using this kit, I assume. It is called the dynamic loading kit. And in order to take advantage of that dynamic loading, you will need to provide a player. I've added a player to my scene already, and I will drag the transform, which I'll do by simply dragging the actual game object. One thing to make sure of is that you might have multiple objects on your player. Make sure to drag the object that actually has the transform that will be changing as your player moves around the world. So this graphics game object, for instance, which is a child of this first-person controller, as the player moves around the world, that position does not reflect the player's position in the world, whereas the position of this transform does. Once you've dragged the player, you'll see two additional fields, the boundary monitor and the player mover. The boundary monitor is the component that's actually responsible for tracking the player and determining whether one of the inner area boundaries of the active grid, so one of these red lines, has been crossed. It's a pretty straightforward component, so I'm just going to add it now. Create another empty game object. Name it boundary monitor, and go into component dynamic loading kit, secondary components, boundary monitor. The only option on the boundary monitor is the detection frequency, which determines the frequency that the player's position will be checked to determine whether one of the boundaries has been crossed. You can leave it at its default value of 0.5 for now. So we'll drag that boundary monitor onto the field, and when you do that, you're going to see two new options here. Monitor inner area boundaries is going to determine whether the inner areas of your active grid are actually monitored. You can disable that if you want the grid to be loaded, but you don't want the grid to shift as the player moves around. Most likely you will want to leave that option enabled. For the monitor reset boundaries option, let's take a look at our world component, and you'll remember that we had to specify whether the layers, rows, and columns were endless, and I specified that I wanted the columns to be endless. What this means is that, let's say we have a 4x4 world. So this world is 4x4 cells. Now initially, let's say we have an active grid here. Good enough. So initially, these cells for this world will be loaded on the original world. But as this grid shifts to the right, because our columns are endless, this world is going to repeat itself over and over again. So repeat once, repeat twice, and it'll just keep repeating endlessly. And this is what allows you to have an endless world. Of course, if this grid shifted up, I got one good arrow. If this grid shifted up because our rows are not endless, the active grid will have these cells activated, but there will be no, the world will not in turn activate any objects. So the player, let's say you had a player here, and he's moving up, he would just walk off the edge of the world basically. Whereas this, he would never walk off the edge of the world, going in the horizontal direction. Now that's fine. The problem is, as we move farther and farther away from the origin, which we'll say is at 0, 0, and 0, you're going to start seeing floating point accuracy errors. So we can't just have this world allowed to just keep repeating endlessly. We need some way to reset it back to the origin. That's what the monitor reset boundaries option does. If we check that, then the boundary monitor, in addition to monitoring the inner area boundaries of the active grid, it's going to monitor another set of boundaries, and when the player crosses those boundaries, the active grid is reset back to the world, or back to the original world. So, for example, let's say that we specify a column repeats value of 2. This means we want to let the world repeat twice before resetting. So as the active grid shifts to the right, the world resets for the first time. The world resets for the second time. But then rather than reset or repeat the world for the third time, instead the active grid is shifted back to its original location. This ensures that the active grid and the world never shift too far away from the origin. Now, of course, in order for these settings to have any meaning, the world that the active grid is synced to must have one of these endless options checked. So, because this active grid is synced to this world here and the rows are not endless, this row repeat setting really doesn't matter. Now, you can sync your active grid to different worlds during your game. So at some point, this row repeat setting might matter if the row that you sync to does have its rows endless. And you can change these settings in addition to really any of these other settings. You can change those mid-game via method calls. Now the last option on the active grid is the player mover. The player mover basically moves the player when the active grid needs to move the player. And the player is moved as a result of certain method calls on the active grid. For instance, there's a method call that allows you to move the player to a different location in the world. And the player also needs to be moved when the grid is reset. For example, here, when the active grid shifts past this point and the grid is reset back to its original location, well, the player needs to be reset as well. The problem with that is, well, first of all, if you don't provide a player mover, then the player's position is going to be moved via its transform. So, for instance, we'll just reset it back to 0. Now that can cause issues sometimes because moving the player via its transform is not always a smart idea. It can sometimes result in the player falling through the world. For instance, my first-person controller, because I'm using a character controller component, I can't simply change its transform position because the player is going to fall through the world. The solution that I've come up with is to allow you to create your own class that derives from player mover, And then you just need to implement 2 of these methods that will move the player, and that allows you to decide how the player should be moved. It allows you to move the player without having them fall through the world. Now, I've done some limited testing with the rigid bodies, and I haven't found that there's any issues with the player falling through the world, but don't quote me on that. Go ahead and do your own testing to make sure. And I know this is a little confusing, so I will be making another tutorial video on the player mover, and you can hover over the tooltip here to see more information about it as well. Alright, so that covers the configuration of our active grid. Thanks for watching.